Okay, so I started this table and it should be on your second day of day 9. And I want to run through this with you. When we talk about f of x, we have a visual representation, we have a verbal one, and then we have a mathematical way of describing our function using our first derivative. Okay, so if your function is increasing, that's what you would say, then it should be moving up from left to right. That's what it would look like. Okay, if your function is decreasing, then it should be moving down from left to right. If your function is constant, so I showed you this in that last graph, notice it shouldn't be increasing or decreasing, right there. And then if your function is flatline, all the y values equal each other, then that would be another area where your function is constant. If your function is concave up, then the function should be smiling. If your function is concave down, your function should be frowning. If you're at a point of inflection, then you should be going from concave down to concave up, or vice versa. Concave up to concave down. Okay, so what we would like to do now is not just have a visual and a verbal representation. We like to have a mathematical representation. Okay, so instead, let's talk about f prime of x. What is the slopes of your tangent line looks like? So if your function is increasing and it's moving upward, you should be able to see that if we draw in the tangent line like that, that would be a positive slope. Okay, so if we go over here, you'll notice I wrote exactly that. The slope of the tangent line at x is positive. We go over here, we look at f decreasing. If we were to draw in the tangent line, look like that. So your slope is negative. And then every point where your function is constant, you would expect to have zero slope here, zero slope at that highest point, and zero slope at this lowest point. So that's what you have here. Now I will get to the rest of the things that are in the table right here, but I'm not going to do it today, right? So what I'm going to focus on is just f increasing should be moving up, f prime is positive, f decreasing should be moving down, f prime is negative, f constant should be looking like these three options, and you should have a derivative of 0. All right, so I wanted to show you this picture that you have in your notes, and this is what I put in your notes. And then right after that, you see a bunch of descriptions just like your last homework assignment. But I'm going to focus only on the 3 at the end. Right, you guys can fill the rest of them out. Let me move this up so that we can see what's occurring. Okay. So if you look very closely at what those last 3 say, they say, what happens when f prime is positive, when f prime is negative, and when f prime is 0? Now what I always do is I look at the function, I say, what's that labeled as? And this says f. And so what I'm going to do is I'm going to code switch because these say f prime. So this says when you have the slope of your tangent line is positive, means your function looks like this, which means your function has to be increasing. This one says the slope of your tangent line is negative, means your function's coming down like that, which means f is decreasing. And then lastly, this says what happens when f prime equals 0. So that means your function looks like this in some form, which means f is constant. Okay, so now that I've code switched, these problems become a lot easier, and you're going to have to do a lot of code switching in your near future. So let me go over here really quickly, see if we can identify this. I'm not going to try to zoom in. Oftentimes I won't be able to zoom in because the picture's too big. However, this says where is f increasing? A works. Where else is f increasing? I think E works. F works and G works. The next one says where is f decreasing? Your function should be coming down right here at C. If we were on a roller coaster ride, your function would decrease through C. and then also at I. And then the last one says, where is your function constant? There's only one, okay? And that is at H.